is Maddie and I'm a pre-service teacher at the University of Utah, and today we are going to be doing a lesson about triangles and geometry and relating that to art. So we're going to read a story and then we're going to do an art project related to that. Our story today is Triangles by David A. Adler, and we're going to be learning about triangles and all their different properties. So we see here are some examples of different triangles and what we might name them depending on what different characteristics they have. Make 3 dots on a sheet of paper. The dots should not be in a straight line. Use a ruler as a guide and connect the dots. Do you see it? Do you see the triangle? A triangle is a flat, closed figure with just 3 sides. Draw lots of dots, lots of lines, and lots of triangles. Each triangle has 3 sides. Each triangle also has 3 angles. An angle is what's made when 2 straight lines meet. The 2 lines are the sides of the angle. The point where they meet is called the vertex. So we see each of these blue dots here is a vertex. Look around this room. There are lots of lines. Do you see lots of angles? Do you see lots of triangles? Angles and triangles are everywhere. Angles have names. The name of this angle is ABC. The name of this angle is LMN. 3 letters are used to name an angle. The center letter is always the vertex. So we see here in angle ABC, B is the vertex, and in triangle LMN, M is the vertex. Here's an analog clock with 2 hands, an hour hand and a minute hand. At noon, both hands point to 12. As the time passes, the minute hand moves quickly around the dial. The hour hand moves more slowly. The 2 hands form an angle. Do you see it? Do you see the angle made by the clock's 2 hands? As the hands move, the angle changes. As the minutes pass, the distance between the 2 hands of the clock gets greater. The greater the distance between the 2 hands, the larger the angle. So we see here, these hands have more of a distance than these hands, so this angle is going to be greater than that one. The size of an angle is measured in degrees. Angle ABC is 45 degrees. Angle DEF is 90 degrees. Angle GHI is 135 degrees. We see all those different angles and degrees in this picture. This tool is called a protractor. It is used to measure angles. This sign means angle. This sign means degrees. Angles go from 0 degrees to 360 degrees. Every circle has 360 degrees. An angle that is less than 90 degrees is called an acute angle. An angle that is exactly 90 degrees is called a right angle. You see right angles at the corners of every square and rectangle. So here we have these squares and rectangles, and every corner is 90 degrees. An angle from 90 degrees to 180 degrees is called an obtuse angle. An angle that is exactly 180 degrees is called a straight angle. An angle from 180 degrees to 360 degrees is called a reflex angle. Triangles also have names. Triangles are named according to the sizes of their angles. Here are lots of triangles. All 3 angles in triangle ABC are acute angles. Triangle ABC is an acute triangle, which means that all the angles are less than 90 degrees. One angle in triangle DEF is a right angle. Triangle DEF is a right triangle. You see here, E is a right triangle. There's a right angle. One angle in triangle XYZ is an obtuse angle. Triangle XYZ is an obtuse triangle. We see angle Y is an obtuse angle. Triangles are also named according to the relative length of their sides. Here are lots of triangles. Do you see a triangle in which all 3 sides are the exact same length? That's an equilateral triangle. Here's some examples of equilateral triangles. Look at the angles of the equilateral triangle. If all the sides are the same length, all the angles are the same size. Do you see a triangle in which 2 sides are the exact same length? That's an isosceles triangle. In an isosceles triangle, the angles opposite the 2 equal sides are also equal. So we see if these 2 sides are the same length, these 2 angles have the same measurement. And here are some examples of isosceles triangles. Do you see a triangle in which all 3 sides are different lengths? That's a scalene triangle. Look at the scalene triangle. The smallest side is opposite the smallest angle of the triangle. The largest side is opposite the largest angle. All three sides of a scalene triangle are different. All three angles are also different. And here we have examples of scalene triangles. Are you a good triangle detective? Look at these triangles. Do you see any two that are the same shape? If they're the same shape, the measure of their three angles is the same. Triangles with the similar shape, the same sized angles, are said to be similar. Look at these triangles again. Do you see any two that are exactly the same size? Triangles with angles and sides that are the same size are said to be congruent. So here we have examples of similar triangles and congruent triangles. Bend your arm. Do you see an angle? Hold up your hand. Spread your fingers apart. Do you see angles? I see angles between my fingers and at my elbow right here, and I can change the dimension of that angle. Your lower arm and upper arm form an angle. Your elbow is the vertex of the angle. Can you all do that? Can you show me the vertex of your angle? Can you find any acute angles? Can you find any right angles? Can you find any obtuse angles? Be on the lookout for angles and triangles everywhere you go. And here we see this robot has all these different angles. The R means it's a right angle, A means acute, and O means obtuse. So we see this robot's body is made up of all different kinds of angles. Our first activity is going to be playing Triangle Detective. I need you to find at least 3 objects in your area that have an angle. It can be an acute angle, a right angle, or an obtuse angle, and you're welcome to grab more than that if you would like. And if you have a protractor, now would be a great time to grab that so you can measure the angles of your objects. Here are some objects I found in my house that have angles. The first object I brought is a Rubik's Cube. Since a Rubik's Cube is made of squares, I know that every single vertex has to have a 90-degree angle, making it a right angle. So this Rubik's Cube is made up of right angles. And in fact, my stand here also has more angles. This is an equilateral triangle. The side lengths are the same, as well as the angle measurements are the same. The next object I brought is my hair straightener. My hair straightener has an acute angle. We see here, it is a less than 90 degrees at the angle. The next object I found is a pair of scissors. This can actually go from an acute angle all the way up as it gets to 90 degrees to a right angle, and it can even become obtuse. So this is an object that you can change the angle measurement of. The last object I brought was an envelope. This envelope has lots of angles, but I'm going to be focusing on this one right here. Now, it may look like a right angle, but if you have a protractor, you are able to see that it's not actually a right angle. It goes to about 95 degrees right here, making it an obtuse angle. We're now going to do an art project where you are able to play Triangle Detective and make your own piece of artwork. For this project, you will need either a piece of paper or a whiteboard, as well as markers for the whiteboard, or paints or markers or colored pencils for the piece of paper, however you would like to do it. If you'd like to keep your artwork, I would suggest you use a piece of paper and then something that will stay there instead of a whiteboard, which you can erase. For this project, I'm going to use a whiteboard. Your first step is to create lots of different intersecting lines on this piece of paper or whiteboard you have. And you want to go all over the piece of paper. And your goal with this is to create lots of different triangles. And sometimes you may end up with shapes that have 4 or 5 sides. So in that case, you don't have to make the lines go from edge to edge of your piece of paper, but you can make them just inside each shape so that you are left with only triangles. So here that happened to me a couple times. So I'm going through like this and adding lines so that every single shape in my piece of artwork is a triangle. So here we have another quadrilateral. So I'm going to cut that, and another one right here, and I'm going to cut that. There we go. The next step is to color in half of the triangles on your piece of paper. You're going to try to leave every other space white, but if that's not totally possible, don't worry, it'll be okay. Now I've colored in about half my triangles, and with the blank triangles, we're going to check which ones are acute, right, and obtuse, and label them. Now we aren't gonna label them with the words, but we're gonna pick a color for each angle. So for mine, I'm gonna have my acute angles be blue, my right angles be pink, and my obtuse angles be purple. And this is also a point where your protractor will come in handy if you have one, because some angles like this might look right, but if we check with the protractor, we can see that it's actually obtuse. So for that one, I'm going to mark a purple semicircle, and I'm gonna go through and mark all of my acute angles with blue, and my right angles with pink, and my obtuse angles with purple. Here is my artwork after marking all of the angles. If you see, most of my angles ended up being acute, some were obtuse, and I only had one right angle, which is okay. Sometimes you won't have you'll have differing angles than your friends, and right angles are a lot less likely to happen because it has to be exactly 90 degrees, whereas there's a lot of options for acute and obtuse angles. I hope you all had lots of fun today reading our story about triangles and then applying that knowledge you learned to our art project today. I know I had lots of fun making my artwork, and I'm excited to show all of my friends my triangle art. Have a good day.